5.2 is right triangle trigonometry. Some people get a little intimidated by trigonometry, but it's really not that bad. Right, there are 6 trigonometric functions. They're sine, cosine, tangent, cosecant, secant, and cotangent. Now might be a good time to pause and then copy everything down so that you can follow along and just listen. When I'm talking about these 6 functions, what we're actually just talking about are ratios of sides in relation to the angle that you've chosen and called theta. So the 6 trigonometric functions are just ratios of the sides of a right triangle. I have theta right here, and so the side across from it is my opposite side of my triangle. My right triangle, my right angle right here, the one across from it is always my hypotenuse, and then the angle, if it's touching the side but it's not the hypotenuse, this has to be the adjacent side. So adjacent meaning right next to it. I just labeled these O, H, and A for the sake of ease instead of writing everything out here. But if you want to write everything out, that's fine. That's what they stand for. O, H, and A, opposite, hypotenuse, and adjacent. So sine of theta is just the ratio of the opposite side, so whatever this is, over my hypotenuse. So O over H. Cosine is the adjacent over the hypotenuse, and tangent is my opposite over the adjacent. Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So sine and cosecant go together, cosine and secant go together, and tangent and cotangent go together. So to get from sine to cosecant, all I do is flip it. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So when it says using the triangle at right, determine the exact values of all 6 trigonometric functions of theta. I can tell, just without even knowing what this angle is, what sine, cosine, tangent, cosecant, secant, and cotangent are of this angle theta. I'm not looking for theta here. I'm not going to have a theta equals. I'm looking for sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. Think of them as function machines. What you put in, what's happening in the function machine is it's taking the opposite side measure and the hypotenuse side measure and just putting them over each other into a ratio. So first thing I need to do is find this other side right here. And so this piece right here, find the missing piece of a right triangle, the missing leg. I can use Pythagorean's theorem, and that gives me a squared plus b squared equals c squared. Or if I have any past knowledge from geometry or another course I've taken, and I know anything about Pythagorean triples, I know that this is a 3, 4, 5 triangle. So if you need to work that out, it's going to end up being 3 squared plus 4 squared equals c squared, because c is always your hypotenuse. You end up with 9 plus 16 equals c squared. 25 equals c squared. Sure, c squared could be positive or negative 5, but we're talking about a measure here, and so I'm going to use positive 5. So c in this case is 5. Therefore, sine of theta is equal to the opposite over the hypotenuse. If this is theta, then this side must be the opposite. This is the opposite. This is my adjacent, and this is my hypotenuse. So the opposite over the hypotenuse gives me 4 over 5. The adjacent over the hypotenuse gives me 3 over 5. And the opposite, which is 4, over the adjacent, which is 3, is tangent of theta. I go the other way. So cosecant, which is hypotenuse over opposite, I either flip sine, that's one way to get it, or I can go to my triangle and say, okay, the hypotenuse is 5, my opposite is 4, my hypotenuse is 5, my adjacent is 3, and the adjacent is 3, and the opposite is 4. So there are the exact values of all 6 trigonometric functions of that angle theta. Keep in mind, I don't even know what the measure of theta is, but I can find all 6 trigonometric functions. There are 2 triangles we're going to see very often in trigonometry. The trigonometric functions of these triangles are very common, and it's important that you know how to find them. If you do not understand how to find them, you must memorize them. I can tell you right now, it's a lot easier to understand where it's coming from, be able to figure it out, as opposed to just jamming all this information into your brain. The more you use them, the more you push yourself to practice and use this information instead of relying on a book or a calculator, the easier it's going to be. Also, I'm going to force you guys to not use calculators and to look for exact values, so you must know these triangles. Now would probably be a good time to pause and jot this stuff down before we get started. All right, so the first triangle we're looking at is a 30, 60, 90. It's very common, and the sides are 1 across from the 30. Keep in mind that the smallest side is across from the smallest angle. So 30 is my smallest angle. 1 is less than the square root of 3. So 1 is across from the 30, square root of 3 across from the 60, and then 2 is across from the right angle. Your hypotenuse should always be the longest. The other triangle is a 45, 45, 90. The nice thing here is it's a 1 and a 1. It doesn't matter which one goes where, and then a radical 2 on your hypotenuse. So the sine of 30, I'm going to have to do two separate triangles here basically. So the sine of 30, if this is 30, that means that this is the opposite, this is my adjacent, and this is my hypotenuse. Whereas when I do 60, I'm going to color code these. This will be my opposite, this will be my adjacent, and my hypotenuse stays the same. So for 30, the sine of 30 is going to be opposite, which is 1 over hypotenuse, which is 2. The cosine of 30 is going to be the adjacent, which is radical 3, over the hypotenuse, which is 2. And then the opposite, which is 1, over the adjacent, which is radical 3. But I can't leave a radical 3 in the denominator there. I rationalize. If you need to remember a refresher on how to rationalize the denominator, you multiply top and bottom by the bottom radical. So I multiply this top and bottom by radical 3, and I end up with radical 3 over 3. This is the number I expect you to remember. This is the number I expect, because this is not technically proper form. This is okay because this is really just a giant 1, but I multiply top and bottom by that radical and end up with radical 3 over 3. So now we'll move on to sine. So sine of 60, which is opposite over hypotenuse, I'm using the orange now because 60 is my orange angle. So it's radical 3 over 2. Cosine, the adjacent over the hypotenuse, is 1 over 2. And then tangent of 60, which is opposite over adjacent, leaves me with radical 3 over 1, which is just radical 3. So either you can draw yourself the triangle and then come up with those pieces, or you memorize that. The other triangle, the 45, 45, 90, is a little easier because it's the same for either angle. So I end up with sine. It doesn't matter if I call this theta or if I call this theta, they're the same number. So it doesn't matter. So 45, 45, 90, opposite over hypotenuse gives me 1 over radical 2. Again, I can't leave that though, so I rationalize by multiplying top and bottom by radical 2. This is really just a giant 1, so it doesn't change the value, I'm just changing the appearance. And I get radical 2 over 2. The adjacent over hypotenuse gives me the same thing, so it's also radical 2 over 2. And then opposite over adjacent gives me 1 over 1, which is just 1. So again, you either have those memorized or you can come up with those triangles and figure it out for yourself. As I said in the beginning, this section of the chapter is just a big information dump. So again, probably not a bad time to pause, write everything down, and then tune back in when you're ready to listen. The first chunk here, these are just your trigonometric identities. It's how everything is related to each other. Identity meaning true, always, without a doubt. No matter what value you plug in there, it must be true. So your reciprocals identities, like I said, sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. Tangent is the reciprocal of cotangent. So how do you find a reciprocal? Flip it over. Just put it over 1. So sine is equal to 1 over cosecant. Cosine is equal to 1 over secant. Tangent is equal to 1 over cotangent. Cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tangent. Quotient identity, quotient, we're talking what operation? Talking division when we talk about quotients. So when you divide sine by cosine, you end up with tangent of theta. Again, since tangent and cotangent are reciprocals, if tangent is equal to sine over cosine, therefore cotangent must just be the flip. So cotangent is equal to cosine over sine. Your last identities here are your Pythagorean identities. And they just say Pythagorean theorem, think of that, a squared plus b squared equals c squared. Sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared. And 1 plus cotangent squared is equal to cosecant squared. I'm going to derive them really quickly for you on the side here so that, again, if you can at least remember this one, you'll be set to come up with the others without having to memorize those bottom two. So here's how I'm going to derive this. So if I have sine squared plus cosine squared is equal to 1, I ditched the thetas just out of laziness, but if they're really still there, if you'd like them, you can keep them. But here's how I'm going to get from one identity to the next. I'm going to divide each piece here by cosine squared. And then I'm going to rely on my other identities to simplify this. So sine squared divided by cosine squared. Well, sine divided by cosine is tangent. So sine squared divided by cosine squared must be tangent squared plus cosine squared divided by cosine squared is 1. And 1 over cosine is equal to secant, so 1 over cosine squared must be secant squared. There is your second Pythagorean identity. All I did was divide each piece by cosine. So now you're going to see what happens if I divide each piece by sine squared. So I divide each piece here by sine squared. I end up with sine squared divided by sine squared is 1. Cosine squared divided by sine squared is, well, cotangent is cosine divided by sine, so cosine squared divided by sine squared must be cotangent squared. And 1 over sine is equal to cosecant, so 1 over sine squared must be cosecant squared. So here's your third Pythagorean identity. Again, if you can remember the first one, sine squared plus cosine squared equals 1, divide each piece by sine squared, and then again divide each piece by cosine squared, you can derive your two other identities. Then you don't have to memorize everything. It's just one step easier, and it helps you practice those reciprocal and quotient identities in the meantime. The next couple examples are applications of using these identities when they're asking for certain values or certain trigonometric functions, as well as simplifying, and then some angle of elevation, angle of depression, which we are going to do in class. The essential thing is that you have these really key pieces written down, and then we're going to learn how to apply them.